Hello. In this video, I'm going to show you how to do data preparation with Skytree. So data preparation really is the first step in any kind of modeling, and it is the first step in modeling with Skytree as well. And data preparation with Skytree consists of two steps. The first step is the generate header step, and the second step is the convert data step. The generate header step basically consists of letting Skytree go over your data files to extract summary information into something called a header file. And once that header file is written out, you can go to the convert data step, which consists of using the header file to put the data into a format that Skytree can work with, a Skytree native format. This Skytree native format is really a very simple format. It's a comma-separated value format with a few reserved rows and columns that Skytree needs. So in this exercise, we're going to use the famous adult or income data set that comes from the University of California, Irvine machine learning data sets. And this is actually shipped with Skytree, so you don't need to download it. You can find it in the directory called datasets under the Skytree server directory. And there are many files in that directory. We will just use the income.data and income.test files. So let me begin by creating a directory for the exercises. And go into that directory. So I will copy the data files from the Skytree datasets folder. On my machine, Skytree is installed under the opt folder. And I begin by copying the income.data file into my current directory. And then I copy the income.test file. So now I have these two files in my current directory. So let's just take a quick look at these files. Okay, so we see that this file has many columns, and the first line of the file gives us the column names. Some columns are numerical, some columns are categorical. And we also see that some of the values are missing, and that's represented by a question mark. And if we open the test file, we see that it has the exact same structure, but it has different data points, and it has a different number of total data points. This data set has 15 columns, and each column represents some sort of demographic information about people. The first column is the age of the people, and the second column is the work class, and the third column is something we're going to ignore. The fourth column is the education level, and the fifth column is the numerical version of the education, and so on. The last column represents the income of the people, and it's a binary variable. It tells whether the income is greater than $50,000 a year, or it's less than or equal to $50,000 a year. The problem that we're going to solve with this data set is to predict the last column using the demographic information given in the remaining columns. So we would like to predict whether the income of a person is greater than $50,000 a year or less than $50,000 a year using the demographic information given in the other columns. We will train and tune our models using income.data file, and we will not use income.test until we're ready to evaluate our final models. So the first step that we're going to take is to generate the header file. Generating a header with Skytree is done by using the generateHeader.sh script. This is a script that comes with Skytree server, and what this does is it goes over the files that you specify, and it obtains dictionaries for categorical columns, meaning it extracts the unique values that occur in each categorical column, and it also extracts basic statistics for the numerical columns. So let's do a simple run to generate a header. We will specify the input file as income.data. We will specify the header file that we're going to write out. as income.data.simple.header. So this is a simple header file that we're going to write out. And we will tell Skytree to ignore the first line because that is just the column names. It's not a data line. And we will also tell Skytree that that is actually the line that has the column names by using the use column names option. So let's give this simple run to generate a header. As you can see, during the run, Skytree begins by giving some basic system information, and then we see the progress information, starting headers generation, getting the information, type information from the files, and so on. And in the end, it just tells us that the header generation has been completed. So we also see that the exact command line arguments that we used are printed out during this run. So this is a common thing with Skytree. Whenever Skytree begins a particular run, it will print out the exact command line arguments that were used. So let's open the header file that we generated and inspect it. So this is a simple text file that starts with a couple of command lines. Any line that starts with a number symbol is a command line that's ignored by Skytree. So it just gives some basic information about the data. And you can see that the numerical columns have been identified as integers and the text columns have been identified as categoricals. And for numerical columns, we see that there's some basic statistical information reported, like the minimum value, maximum value, mean, and the standard deviation. And for the categorical columns, we see that a dictionary is reported, where by a dictionary, I mean the list of unique values that appear in that column. So this header file is going to be used by Skytree to convert the data into the native Skytree format. Another important thing to note is that Skytree has identified the column delimiter as a comma. That's the default delimiter. And if you would like to use another delimiter, you can specify that to the generate header script. And when we look at the dictionaries, we see that the question mark actually appears in the dictionaries for some of the categorical columns. In this data set, the question mark actually represents a missing value. And we do not want to treat it as just another category, but we actually want to make sure that that is identified as the missing value symbol. So we'll do that in the next run. So in this simple run, we did not identify the question mark as the missing value symbol. And another thing we did not do was identify the yearly income column as the prediction target column. So let's next give a run where we actually take care of these things. So this is almost identical to the previous run, but the only two differences are that we now specify the label index option as the 15, column number 15, and we specify the missing value symbol as a question mark. Let's next give this run. So once again, we see that the generate header script starts by giving some general information about the system that we're working on, and then it just gives us progress information about the run. So let's now open the header file that we generated, which is now called income.header. So we now see that the question mark has been identified as the missing value symbol, and it does not appear in the dictionaries. We used only a single input file for the generate header step, but it is possible to have multiple files that contain our data. So in that case, one would still use the generate header script, but would specify more than one file. And this would be done by just specifying the file option multiple times. And if the files have different numbers of lines to ignore, you can still specify the ignore line step once for each file. And the number of lines you specify are going to be used for the files in the same order that you specify the files themselves. We saw that in the header that was generated, the textual columns were identified as categoricals, and the numerical columns were identified as numericals. But sometimes numbers actually represent categories rather than actual numerical values or sizes. So in that case, we would want to identify the numerical columns that represent categories as actually categorical columns. So that can be done in two ways, depending on the way we want to treat the numbers. So if we want to treat something like 100 and 100 preceded by a 0 or 100.0 as distinct categories, then we use the categorical text option and specify the column that we want to treat as categorical text. If you want to treat these three options as the same category, then we would specify the categorical number option by giving either the name or the index of that particular column. After we generate the header, we're ready for the convert data step. And we will convert both the training file and the test file using the same header format that we generated using the training file. So there are just a few considerations when we're converting the data. We will need to specify the header file that we generated. And for each data file, we will write out two files, one for the input columns using the data out option of convert data, and the other one for the label column using the labels out option of the convert data. Some of the columns may not be useful and we may want to exclude them, and for that we use the ignore columns option. And finally, we need to specify the label index and the ignore lines option once again, just as we did in the generate header step. So here's a run that converts the training set, which is in the file income.data. So as you can see, we specify the file as income.data, and we're specifying the header file that we wrote out using the header in option. And we specify once again the number of lines to ignore, and we specify the label index, and we're ignoring column number 3 in this particular file, and we're writing out the data, the input columns of the data to income.data.st, and we're writing out the labels to the file income.data.labels. Okay, so let's give this convert data run. So we see that Skytree once again starts by giving some basic system information and then the exact command line arguments that we used in this particular run. There are two warnings that we're going to ignore for now. They're about ignore out of range, clamp out of range options, and missing values. So the files have been written out, so let's take a look at them. So this is the data file that we wrote out. This is the Skytree internal format. And as you can see, this is simply a comma-separated value file where all the data is represented by numbers. So the categorical columns have actually been converted to a numerical representation in terms of integers. The file starts with a few command lines. So every line that starts with a pound sign, the number sign, is actually a command line that's ignored by Skytree. But this has useful information about the data, the dictionaries for the categorical columns, as we have seen in the header file. And after these command lines, we see two lines that give some meta information about the data set. One of these lines starts with the word header, and it just tells the numbers of different types of columns. So there are 3 meta columns. Those are the columns that are used by Skytree for internal purposes. There are 5 real columns, so numerical columns, and 8 integer columns that represent the categorical variables. And after this line, we see another line that gives some information about the data, and that line has the attribute names. So those are the column names that we extracted from the first line of our original data file. And after this, we see that the data follows in a comma-separated value format. We should note that the order of the columns actually has been shuffled. The categorical columns are now collected at the end. So the last 8 columns are the categorical columns, and the 5 columns before that, designated real in the header line, are the numerical columns in the original data set. And the first three columns, as we already mentioned, are the meta columns used by Skytree. So the attribute names, starting with age, education, num, capital gain, those actually refer to columns starting at column number 4 and going onwards. So the first three columns are for Skytree internal purposes. Those are the meta columns. Let's also take a look at the labels file that we wrote up. As you can see, the two categories, income being less than 50K or greater than 50K, have actually been converted to plus or minus 1. And this is the convention Skytree uses for binary classification problems. But if you have a multi-class classification problem, the internal representation of the classes would start at 0 and go up like 0, 1, 2, 3. The ordering of the integer representation of the classes is done in a lexicographical way, meaning that, for example, if my classes were represented by the letters A, B, and C in the original data set, A will get to be class number 0, B will get to be class number 1, and C will get to be class number 2 in the Skytree internal representation. And likewise, if I have a binary classification problem, the ordering is again lexicographical. So we next do the same thing with the test set. So we're using the same header file that we generated using only the training set. So we're pretending that we don't have access to the test set. So the header file dictionaries are only generated using the training set. So that means if in the test set we have categories that did not occur in the training set, those categories will not appear in the header file. So the convert data step in that case actually sets those categories to missing values. So let's next give this run. And let's take a quick look at the files that we generated. So this is the test file converted into Skytree format. As you can see, it's pretty similar to the converted version of the training file. And this is the labels file. While certain machine learning methods such as gradient boosted trees or random forests can easily deal with categorical inputs, certain other methods like nearest neighbors classifiers actually need to have numerical columns only. So when we have a data set with categorical columns, and if we want to use something like nearest neighbors classifiers, we would need to convert the categorical columns into numerical columns. So horizontalization is one common way to do this, and it's known by other names as well, like one-hot encoding or using dummy variables. So it's a really simple method. So suppose we have a column named color, which has three categories, red, green, and blue. To horizontalize this column, all we need to do is remove this column and replace it with three new columns. Let's call them color red, color green, and color blue. And for each data point, we simply set the appropriate column to 1 and all the others to 0. So if one data point has color red, we would set the color red column to 1 and color green and color blue columns to 0. So we apply this to all the categorical columns in the data set, and that would of course increase the number of columns of the data set, but it would allow us to use machine learning methods that only work with numerical columns. Skytree uses a convention where the constant value that occurs in the horizontalized columns is not 1, but it's 1 over square root of 2. This is simply a convention, and it just makes the distance between distinct categories equal to 1. So when you calculate Euclidean distance between two categories, if you set the horizontalized columns non-zero values to 1, then the distance between two distinct categories would be square root of 2. So using the Skytree convention, this distance becomes 1. So let's give this convert data run with the horizontalize option. So we're specifying new file names now for the horizontalized version of the data set. And let's take a quick look at the horizontalized version of the data set. So now we see that the initial command lines are much more numerous than before. We have multiple columns for each categorical column, one for each category that occurs in a given column. And the header line now tells us that there are 3 meta columns and 104 real columns. So all the categorical columns are now represented by real columns, numerical columns. And the attribute names are also numerous. And we see that, for example, for the work class column, there's a work class federal gov column, work class local gov column, work class never worked column. So multiple horizontalized columns are inserted in place of each categorical column. And let's take a quick look at the labels file, which shouldn't change at all because we did not do anything specific to the labels file. So this is exactly as before. And finally, we're going to do the same thing with the test set by converting the test set into Skytree format, but this time using the -horizontalize option with the convert data script. So this is going to create a horizontalized version of the test set so that we can use it with methods like nearest neighbors. And once again, taking a quick look, we see that the horizontalized version of the test set starts in a similar way to the horizontalized version of the training set. And once again, there are 3 meta columns and 104 real columns. So with this, we're done with the preparation of the income data set, and we can now use the data set to build models using Skytree.